Welcome to our next tutorial of QUICKSURFACE. In this tutorial I'll be using QUICKSURFACE 2025 and we'll take you through the process to start reverse engineering of this part and end up with this cut model. Before I begin, I'd like to say thanks to our partner Shining 3D for the file provided. You can find the link in the description of the video so you can download the actual STL file. But for information about Shining 3D technology, how they scan this object, you can refer to the post also listed into the description. So let's begin. I'll just create a new empty document and we'll open the STL file. Because STL file doesn't have any units, I assume that this is in millimeters. I can just press open. I always advise, before you begin, to actually check the sizes of the imported mesh in terms of the dimensions, so you just don't mix up whether it comes as inches or millimeters. How can we do this? I'll just go and right click on the mesh data into the feature tree and select properties. This shows me that it's around 20 by 20 millimeters, which is where it is in reality. I haven't seen the actual scanning, but I assume this is what we get. As we always know, it's really hard to begin something. You need planning, you need to decide what you want to do and how you want to approach. For this reason, I just always recommend that you start with something which is called Prepare Scan. Prepare Scan is the first option in the toolbar. You can just press the button. The software starts analyzing first of all the size. Now when we speak about the size, we're speaking about the number of triangles that the scanner generates. In many cases, it might be really high dense. As we start here, it has 4 million triangles. But do we really need this? Not always, because you work with a specific tolerance. In this case, by default, is 30 microns. And as you can see, the software tells us that even if we reduce by 50%, still 100% of the points will be within this tolerance. What I mean with this is, if I just check the deviation option, you can see that everything is green, which means it's within 30 microns. I say 30 microns because these technologies generate normally this type of noise, and it's good enough for the quality you get. What I mean is, if I just show the wireframe, you can see how dense these points are, but they don't really carry too much information for us. If I just uncheck the deviation, you see the resulted mesh is much more reduced and still has the same quality. So don't be afraid to apply this polygon reduction first. In this case, I can even try to use down to 1 million triangles, which is about 24%. Analyze, let's see what it will look like. You can see the data are reduced, but still 100% of the points are within this 30 microns tolerance. I will accept this because I like to work with the lighter meshes. This gives us a warning that it will replace the original file. I have the original file on the disk, so I'm okay to continue. Then we're speaking about the mesh quality. In some cases, you may get a mix-up of different floating meshes, holes, if you want to improve. In this case, even if you don't see it, it's actually 3 individual meshes. So there are some small somewhere. I recommend you can just go edit to these individual meshes. I select the big one and tell the software just to leave this one. Now this becomes green, which means it's good. You can spend time to fill the holes, but because this is prismatic shape, I don't really care about this information here. I can press next to move to the next step in our wizard. The software tells me that there might be a symmetry here, which might be useful for the alignment. We'll be using features to align our object, and in this case, I see it's actually symmetrical, although this hole is different. So what I need to do is just click here and then click here to give the software roughly the idea what the symmetry plane looks like. Then I can tell the software to rebuild and find the optimum space of this symmetry plane. This is what we get as a result. I can just press analysis to see how the symmetry is. And what green shows us is a really nice, good symmetry. But here, probably the part is not being perfectly symmetric, and that's why you get this area. I can just press next to accept this symmetry plane. Let me hide this for now. I have this symmetry that will give us one direction, but also I need a z direction and where the object will lay. What I'm going to use here is to extract primitives. With the QUICKSURFACE 2025, we introduce fast and efficient way of what is called segments. When you press the segment, the software will create a segmentation of the data based on the curvature. In this case, I need this shape. I will pre-select to define my cylinder. Here you can see it's rounded. I can play with the slider and just to pick different data, not too much for the cylinder. This looks good. I can just press fit the cylinder. I can analyze my data. Let me make it 30 microns so I can see. What you see here is the deviation from the cylinder because it's not perfectly cylindrical part, but this is what we want to be. So this is how we're going to build our object. I'm happy with this and I will just create this cylinder. Now I can carry on and create my other plane, which is at the bottom. These are several segments. I can click on the first one. Holding the control key, we'll select also the other two segments. That will give us a better presentation for the plane, and press fit plane. You can see it's nice, it's very well defined. It's under the 30 microns. I can even play with the 20 microns to see the deviation, and this is really good. Make sure in this stage you don't have the auto constraints enabled. We don't need it. You can refer to our other tutorials how this functionality works. I'm happy with this. I can just press next and we'll accept this plane. What we have now is we have the three features that mathematically are good enough for me to define the coordinate system. What this means is that I can tell the software that this cylinder will be my z-axis. Then I probably need to flip. Then I can pick the bottom plane. This is where my xy plane will be. And I select the symmetry plane to define my other direction, which is probably this one, xy. I can apply. You can see that now the object is perfectly aligned. And then I can press finish. The software automatically hit the features that I've been using, but they are still in your scene for further reference if you want to. Now my plane and my object is perfectly aligned and we can move to the next step to start the reconstruction. I will save the object for now and we can move to the next step. As we have our object aligned and ready to start, we need to do our reconstruction. This is the cylindrical part and I'm going to create the main body first. I'll be using a 2D sketch. We'll select the 2D sketch. And because it's cylindrical, I'm looking for a revolved surface. I will pick the option which is called revolved surface. Here you can get the cross section that will define my profile for the revolved surface. There are different options here that you can use: the stacked sections, outlining, selection only, and so on, but I'll just leave it for now. If you want to reproduce my steps, just leave this to 345. This is the location where I make the trimming. I'll just press create. What the software did, it created a cross section that's called sketch that I'm going to use to reconstruct my profile. In this case, you can manually extract the lines, but I'll be using our sketch assistant to see how it will help me. Once I press this, it's automatically actually recreated this shape for me, that it's really useful for immediate body creation. As you can see, the software automatically even created the fillets here. I can just turn off the create fillets if I want to do this later, and I can press accept. As you can see now, it's automatically created constraints because they were nearly horizontal or vertical. Only this one I probably need to make it manually just to tell the software that this is horizontal. You can experiment, and with the control key you can create the fillets here if you want to make this rounded like this, or on the other shapes which are here. Just holding the control key and brush over the corners, it automatically will define the rounded fillet for you. Let's do this. I'm happy with this. I can probably do this here and the other one here. Now I'm ready with my profile. You can press OK and then you create your shape, but there are two shortcuts immediately that will take you there. I'll just press the revolve, which means that the software automatically will recreate this shape for me. Because we have the reference line, it's the revolved command automatically decided to pick this as a revolved axis, and then I can press OK. I can go and hide my sketch. So this is my first body that I created. We need to move now to the next step to see how we can create all these openings here. What I'm going to show you now is what we have a row and unroll command. And let's see how it works. I will just show the solid for now. We'll go to scan data and select the command unroll. I will pick the cylinder because this is what it's needed for me to create an unroll. How the unroll command works, it will just take the mesh, unwrap it and flatten it, and this is where the zero origin will be X and Y. I'll just leave it as it is for now, and I press preview, and you can see that this mesh has been actually unrolled down. I can press OK. It's safe to do this because it automatically created another mesh for me for my work. I will hide for now my original one. You can see now that this is a normal mesh that I can work on. You can see the openings here, they're like extruded way, so this is very easy and simple for me to reconstruct the sketch here. Let's try to do this. Let me just save this. Please make sure you save it from time to time so you don't lose your work. And now I'm going to just work with a normal way to create a 2D sketch. I'm going to drag the plane. You can use the arrow or you can just pick the white plane, which is, I assume that this is here. You can just pick the best location that you want so you can create your profile. This looks good to me and I can just create my sketch. Now I have my sketch, and you can recreate it manually, but I'll ask my sketch assist to help me again. Probably I need to create some fillets here, and you see that it's recreated this for me. I will just press accept. Now strategically, because I want to use this as a cutting tool, if I look at the mesh, I will just don't need these areas. We'll just select and delete. Also, I don't need these fillets. You can recreate them later. And what I'm going to do, pick this point and extend. You can see we have a reference line here, so in this way we don't go away from our initial intent. This is what we have now. I can just go and close it with a line like this one. Here you can pay attention on the quality, how it looks like. Perhaps this was not the best way. I can just delete this and improve. This was because of the noise. What I'm going to do here with the control key to intersect and control again to recreate this fillet. You can build this in a more complex way if you want this to be a spline and recreate it here. But for the purposes of demonstration, this is good enough, and this is what we want to do. Perhaps also here you can play if you want to leave this sharp, but I like it as it is right now. I can just press OK to accept this sketch. We'll save it. I'm going to create another sketch which will go way down and press create. What I'm going to use now, instead of extracting, I want to get exactly the same add a sketch, and I'll use the project command. The project command allows you to pick the contours from the other sketches, and they will be recreated into this current sketch. You can see that this is select chain is on, then you can press OK. Now press OK. We have two identical sketches which will be used by me for the next steps. How can we do this? I'll just hide this mesh, I don't need it. Save it. We'll show the original shape. Now you see I have these two sketches, but I also have the roll frame. This is a special frame that has been created that it will be used to put these sketches back in 3D. How this works, I pick the sketch, right click, and select roll to the sketch. The software will automatically use the roll frame and recreate back this sketch into the 3D environment. We'll do the same for the other sketch. Pre-select, right click, roll to the sketch. I will hide the two sketches so you can see the result. What happened is that based on the unroll information, we can put back the sketches as a 3D sketches into onto the original object. Now I can just save this and we'll move to the next step. The next step would be to actually use our loft surface command that will allow us to create these bodies that will go through the main body as a cutters. What I mean with this is I'll just go to surfacing, loft. Make sure the selected change is on. I'll pick the first contour and I'll pick the second one. This will create my loft for me. As you can see, this is not enough, so that's why I will use expand by and type in here, for example, 3 millimeters. I use 3 millimeters because this is fair enough. You don't need to go too much further. Press OK. You can see we recreated this shape. I will show again these sketches and repeat. Go to surfacing, loft. Now I pick the other profiles. We'll extend by 3 millimeters. Press OK. And let's do this for the last profiles here. Loft. This one and this one. Extend 3 millimeters. We created our cutters now, and we will move to the next step, which is, as you can see, this is our main body. I'm going to use our trim command. How the trim command works, I select everything, hold left mouse button and select everything on the screen, and then you go to trim. What you can do now, start removing the excess. Just delete this, click here, click here, click here, and now this has been removed. Click on this one. I need to remove this shape, and I need to remove this shape. You can see it actually works as a cutter. Click again, remove this, and remove this. Now you see the software tells me it's a solid body. Then you can press OK. As you can see now, we created the more complex shape of what we are aiming for. Let's take a look what else remains. Yes, I need to create these holes here. How can I do this? I will just use the 2D sketch. Drag the section plane to pick one of the points of the circles and we'll create. In this case, I'll be using just the pattern command for the demonstration. How this works, I'm going to zoom in here, use extract primitives, brush over to fit a circle, and this will be my hole. We'll select it and go to the option which is called duplicate. The duplicate allows you to recreate in two different ways. With the patterns, I can use the circular pattern in this case, and it has exactly 6 instances. You can see the preview. and I can accept. Now, if you remember, I can just press OK and create extrude, but I can just directly press extrude. I can just drag the handles so they can go through the whole object. Let us show the last solid that we had, and what we have here is the option to use this as a cutter so it can go through and cut the shape. Press OK. This is how far we got. And the final steps, we want to create these 3 holes. I will just create my last sketch, drag it here, we'll create it. In this case, for the demonstration, I will just quickly create the 3 circles, but feel free to use the pattern again if you want to be more precise. Press back, create extrude, extend, make it bigger, big enough, show your solid body, and then choose the command which is cut. Press OK. This is how far we went in our demonstration. You can see we started with this shape, which is quite complex, and in this tutorial we managed to recreate the solid body that we are looking for. I hope this tutorial is useful, and I'll give you a try it yourself. Get the link to download the file in the description, and try to repeat my steps. Thank you for watching.